This preparation has two parts. Firstly, the preparation of the dry silver nitrite we need for the reaction. The second part is the reaction of this with ethyl iodide to form nitroethane. We start by weighing out 42 grams of solid silver nitrate. Add 100 ml of water and stir to dissolve the solid. Be careful not to let this solution contact your skin, otherwise it will stain badly and potentially burn. Next we weigh out 19 grams of sodium nitrate. This is a slight molar excess compared to what we need, but it's important not to waste the valuable silver salt. Dissolve this in 100 ml of water. This may take a bit of stirring to get all the solid into solution. If necessary, add a little more water. Now add the solution of silver nitrate to the sodium nitrite solution. You'll immediately see a yellow precipitate of silver nitrate forming. Stir the mixture well for a good 15 minutes in order to make sure the reaction is complete. You'll end up with a fine, almost white-colored precipitate, like this. Now filter the solid and get as dry as you can initially. Then wash with 40 ml of cold water and get it dry once again. When dry, stop the pump and add 40 ml of absolute ethanol. Stir this together with the solid well so that it can absorb as much water as possible. Then filter off the ethanol and dry again on the pump. Repeat the process with another 40 ml of ethanol. Now get the solid as dry as you can and break any lumps in the filter. Allow air to pass through the solid to dry it further. Here's our silver nitrate. We placed this into a makeshift desiccator with anhydrous calcium chloride for a week in order to get it completely dry. The solid is also apparently slightly light sensitive, so we covered this in aluminum wrap just to be on the safe side. A week later, the solid is dry and ready for the next step in the reaction. We weighed it and had 35 grams of silver nitrite. Place the silver nitrate into a 500 ml flask equipped with a magnetic stir bar. Now measure out 60 ml of diethyl ether. We used normal reagent quality ether with no extra drying. Add this to the flask. The theory here is to have just enough liquid present that magnetic stirring will still work together with the large amount of solid. Add a little more ether if you need to. Now place the flask in an ice and salt bath, which has a temperature of 0 degrees. We then added a thermometer, addition funnel, and reflux condenser to the flask. The condenser is a precautionary measure but might not be needed if your addition is slow and cooling good. Now weigh out 33.7 grams of ethyl iodide. We calculated this based on 95% of the number of moles of silver nitrate used in the reaction, so you'll need to adjust based on the weight of the product from part 1. Add the ethyl iodide to the addition funnel, then add to this a further 30 ml of diethyl ether. Make sure the funnel tap is closed. With the temperature in the flask closed to 0 degrees, you're ready to begin addition. Add the ethyl iodide in ether solution slowly. The aim is for complete addition to take 45 minutes. Make sure your stirring is working well throughout this time. During addition, the temperature will increase. Try to keep the flask contents between 8 to 12 degrees C. Once addition is complete, we removed the addition funnel and kept stirring on the ice bath for a further hour. We occasionally used a metal rod to agitate any solid in the flask which settled out. However, the stirring worked pretty well at keeping the solid suspended. After an hour of stirring in the ice bath, we removed the ice and condenser and stirred the mixture directly, allowing it to come up to room temperature. The stopper is lightly in place so that any pressure buildup can escape. We continued stirring for 4 hours at room temperature. We then performed a test by placing 2 drops of silver nitrite solution and a couple of mils of ethanol into a test tube. We then stopped stirring just for a second and collected a drop of the clear reaction liquid from the flask, and added this to the test tube. You can see the milky-colored result indicated that the reaction is not yet complete. We repeated the test every hour, and after a further 2 hours of vigorous stirring, we observed no milkiness. The mixture had now been stirring for approximately 7 hours in total since the start of the reaction. So we stopped stirring at this point. Filter the reaction mixture, and extract as much liquid as possible from the gray slightly green-colored solid. Wash out the flask, and then the filtered solids thoroughly, with another 2 lots of 50 ml of diethyl ether. Take care when filtering ether, as there is a lot of highly flammable vapor around. Don't have any heat sources present at all, even if they are not direct flames, and use lots of ventilation. On the left is our filtrate, which we'll process next. On the right is our recovered silver iodide. We'll recycle this to get back valuable iodine and silver nitrite for another reaction run. Place the filtrate into a 250 ml flask, and use a water bath to distill off the ether present in the mixture. Alternatively, just evaporate off the ether, but be careful with ether vapor. You're left with 10 to 15 ml of pale yellow liquid in the flask. Any toxic and potentially explosive ethyl nitrate formed as a side product in the reaction should also have evaporated off in previous steps. So set up for distillation, we used an oil bath, and raised the temperature slowly, as the small volume of liquid probably wouldn't have enabled us to measure the vapor temperature accurately. A few mils of liquid distilled over up to 100 degrees C, and we discarded this. As the temperature reached 110 degrees, we noticed bubbles forming, and then boiling at around 115 degrees C, we distilled everything that came off up to an oil bath temperature of 130 degrees. The liquid coming off is colorless, and appears slightly oily in character. We went quite slowly, and total distillation time was around 1 hour. At the end, only a very small amount of orange-colored liquid was present in the boiling flask. Here's our final product, 9.2 grams of pure nitroethane, which corresponds to a yield of 57% based on the ethyl iodide we used in the reaction. The literature references quoted between 50% and 80% yields, so we think this is reasonable. Nitroethane is an important synthetic building block for many organic compounds. There are other ways to make it, but this method seems like the most accessible, provided you have access to ether and the expensive silver salts.